Hello students, welcome to my channel. Please subscribe my channel, press the bell button, press the like button and share it. So today I am going to explaining the one important concept in our physics PUC second year syllabus, that is Einstein's explanation of photoelectric effect. So according to the Einstein, the radiation of energy consists of tiny packets energy, so that he called a photon. Okay, so tiny packets of energy that he called what a photon. Means the radiation, it will be consisting about the packets of energy. This is what we are going to call the packets of energy. He called the word photon, or it is also known as a quanta. Okay, so when these photon falls on the surface of metal, so they collide with the what electron inelastically. Okay, so that will be collided with the electron inelastically. So as we are knowing that it's a combination of wave nature of light and particle nature of the light. So here the two things we have to understand, that Einstein, he combined the water, both wave nature as well as particle nature. So by that he gave the one explanation. As we are knowing that electron is a particle. Electron, it is a one particle. Okay, so photon is a wave nature, that is tiny packets of energy, what we are going to see now. So this is E equal to h nu. So nu, h is represent for the what Planck's constant, and nu it is the frequency. The frequency it will come under the what wave nature. Okay, so waves. In the waves we are going to defining the what frequency means what? The number of oscillations made in 1 second. Okay, so that we are going to call the frequency. So when these tiny packets of energy fall down, there is a collision takes place. So colliding means what? If two particles, they are bombarding with one another. Here that photon, it is a wave nature, it will be collided with the water, this electron. So that energy is going to be absorbed by that electron. After the absorbing, so it will be take the two parts. So one part of that energy, we can see that the part of energy of photon is used to come out from the metal surface, that he called the work function. So this is the when it is absorbed the energy. So that energy when it is absorbed, so then this energy it is utilized for the water, the electron should come out on the surface. So that is the photon energy is used to come out from the metal surface. Okay, so that he called a work function. The some amount of energy it is used for to come out from the what, that electron should come out from the metal surface. So that we are going to call the work function. Okay, so that he called the what, work function. So next, the remaining part of the energy of photon is converted into maximum kinetic energy of electron. So whatever the remaining, it is utilized some energy for the work function. So the remaining energy, whatever it is there, it is utilized for the what? Kinetic energy of that electron. So he divided in two parts. One part for the work function, one part for the kinetic energy. Means the total energy, whatever the energy of incident photon, that will be equal to the work function. That will be equal to the water work function plus kinetic energy of the electron. As we are knowing that law of conservation law of energy. Okay, so conservation law of energy is saying that the total energy remains constant or remains conserved. It means that so whatever the system of that energy it will be there, so that will be what? Constant. It means that so the total energy is equal to the, this is work function, I am thinking that potential energy plus kinetic energy. So potential energy plus kinetic energy. So like that we can think about it. It means that if E equal to h nu is the energy of incident photon. Energy of incident photon. Incident photon. Okay, incident photon. If I think that, so that is E equal to h nu is the energy of the photon. If I thought, then phi naught. This is the what? Phi naught is the work function. Phi naught is called what? Work function. Work function. And that kinetic energy means E, that is a half mv square. Half mv square. Okay, so half mv square means the mass of that electron and the velocity of that electron we are considering here. Okay, so now we want to find out the kinetic, means I am going to write down in terms of the equation. So what he has explained. So then we are move towards the next concept. So you may going to see that this is the energy E equal to h nu, means so I can write down the E equal to, this is phi naught plus half mv square. Half mv square. Okay, half mv square. So this is the E is the energy of the incident photon equal to, this is work function plus half mv square, that is the kinetic energy. Okay, so we can write down, or we can write down the what? E means h nu we have defined equal to phi naught. Okay, plus half mv square. Okay, so as we are knowing that to take place the photoelectric effect, it requires some frequency. That frequency we are going to call the threshold frequency. Okay, so if nu is the threshold frequency, if I think like this way, so if nu equal to nu naught, if nu equal to nu naught, this is called our threshold frequency. Threshold frequency. So threshold frequency means the minimum frequency required for the what? Photoelectric effect. Okay, so that minimum frequency we are going to call threshold frequency, where the photoelectric effect will be start. That we are going to call the what? Threshold frequency. If nu equal to nu naught, so then the kinetic energy equal to what? Half mv square equal to 0. Why I am writing? Because the velocity of the electron is equal to 0. Because still it will be in the inside the metal surface. It will not just, it will come out the what? Metal surface. Okay, so it required the remaining part of the energy. If energy is not there, just it will come out from the what? Metal surface only. Okay, so then this I am going to substitute here. So what we can write down now? So this is phi naught. Phi naught is the work function. So we are going to finding the what? Work function. So we'll substitute here. So nu equal to nu naught means h nu naught equal to, this is phi naught plus, this will be the what? The part of this one is equal to 0. So this is 0. That will be equal to what? 0. This is what we are going to call the equation 1. Okay, so therefore phi equal to what we are getting now? Phi naught, work function equal to h nu naught. This is equation 2. Substitute this value in this equation. Therefore, the equation can be written as, the equation 1 can be written as, okay, can be written as. So see, this value will substitute here. So therefore, h nu equal to h nu naught plus half mv square. Okay, so that is the what? Ultimate equation is given by the Einstein. Okay, Einstein he has given it. Okay, so this is the ultimate equation. So this is very important. So we are going to see that some laws of photoelectric effect, it can be explained by the Einstein's equation. The first we are going to see that the photoelectric effect is a instantaneous. Okay, so according to Einstein, he said that the collision between the photon and electron, the collision between the what? Photon and electron is of the order of 10 to the power of minus 8 second. Minus 8 second. So that means photoelectric effect is a instantaneous. Because the collision between the photon and electron, it's a microparticle. It's a microparticle, we are thinking it. Okay, so they are colliding. It is of the order of 10 to the power of minus 8 second. It is less than the 0 second. Okay, so the second one we are going to see that the velocity of electron V equal to 0. As we are knowing that. So the velocity of the electron V, that is V equal to 0 means kinetic energy is equal to 0. So then we are going to see that work function phi naught equal to h nu naught. It means that, so it required some energy. The minimum energy is required. This work function is also nothing but the what? Energy only. The minimum energy is required. So the minimum energy means the minimum frequency also it is there, because the h nu naught, that minimum frequency is called threshold frequency. Okay, so afterwards only the photoelectric, the electron it is ejecting from the metal surface, and intensity of that radiation is increases. If it is intensity is increasing means it means that it increases the number of photons striking on the metal surface. If the number of photons striking on the metal surface, if it is increases, then it means that the electron, the number of electron which is liberated from the metal surface is also increasing. The number of electron is more, then ultimately we can say that photoelectric current is also increasing. That is the second thing. So next, that is the third thing. So next, the fourth one, it is saying that for a given photoemissive surface, work function is constant. Therefore, frequency increases, the kinetic energy of the photon is also increasing. So it means that, so this is the one constant. So one means one particular metal, if you are taken zinc, okay, other alkali metals, okay, so that metals if you are taken, so then what happens now? It have the work function is constant. So if the increase the photoelectric energy is increasing, means intensity is increases. Okay, so then what happens now? Whatever the energy, it will be taken on constant energy. The remaining energy it is used for increasing the velocity of the electron. Okay, so it will be increase the water velocity of the electron. That means it will be increasing the kinetic energy. That will be increasing the water kinetic energy. So these are the some important laws of photoelectric effect. We can see it. Okay, I hope you people have understood.